The electric power equation has some of the same variables as Ohm's law. The equation is P equals I times V, where I is current and V is voltage and P is power. Now, on a previous page, we used the power equation, P equals work divided by time, in order to solve for electrical work done. You can still do that if you have those variables. It is just more likely, if you're talking about electricity, for you to know current and voltage. So let's look at what we know. A space heater requires 29 amps. That means it's current. From a 120 volt circuit, it's our voltage, to properly warm a room. How much power is this space heater using? So power equals current times voltage, and you get 3,480 watts. Now I know you might be thinking, well, watts is a joule per second. Watts is also amps times voltage. We could derive it for you, but it takes some pretty advanced math, so just trust me on it. It's the same thing. If it's power, it has to be in watts. In the second example, a TV has a power rating of 350 watts. How much current is the TV using when connected to a 120 volt outlet in a home? I say watts so we don't get confused. Since we're not solving for power, you might need a magic triangle. Power, current times voltage. We're solving for current. We have P divided by V. We have 350 watts divided by 120 volts, and you get 2.9 amps. Because this equation uses some of the same variables as Ohm's law, sometimes you will see where you have to use Ohm's law to find the current before you can use this power equation to find the power. So be prepared to have to mix and match with those. There are a lot of different variables in electricity, and in situations like this you just have to know the units. So please make sure you have downloaded that unit and symbol handout and that you know which units go with which variable, particularly in the electricity section. Please try the sample problems below and check your answer before you move on to the assignment.